Good morning all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the video lecture series on properties of Fourier transform in analysis of continuous time signals. First, what is mean by Fourier transform? Fourier transform can be applied for both periodic and non-periodic signals. It can be represented in frequency domain. It provides an effective reversible transformation link between the frequency domain and the time domain representation of the signal. The spacing between the spectral components becomes infinitesimal and hence the frequency spectrum appears to be continuous. Periodic signals has a fixed time period of T0. This is the periodic impulse train with respect to minus 2t to plus 2t. While we taking the Fourier transform of the above function, we can get it as your minus 4 pi by t to plus 4 pi by t in terms of x of omega, that is conversion of frequency domain, time domain to frequency domain with respect to amplitude of 2 pi by t. The continuous time Fourier transform of the signal is given as Fourier transform is equal to x of omega is equal to integral over minus infinite to plus infinite x of t into e power j minus of j omega t into dt. While we taking inverse Fourier transform, x of t is equal to 1 by 2 pi integral over minus infinite to plus infinite x of omega into e power plus omega e power plus j omega t into d omega. While we taking the x of t continuous time Fourier transform pair with x of omega. While we taking x of omega, again we can pair with, we can get it as your x of t. X of t and x of omega forms the continuous time Fourier transform pair. These are the some of the properties of Fourier transform: linearity property, time domain, frequency domain, frequency shifting, conjugation, duality, and then convolution in terms of frequency domain and time domain, differentiation in terms of time domain and frequency domain, and also integration. This is the some of the Fourier transform properties. Next one, we can see the Fourier transform of x of t is equal to u of t. X of f is equal to integral over minus infinite to plus infinite x of t into e power minus j omega 2 pi f t into dt. U of t becomes value 1, the integral over 0 to infinite. Therefore, e power minus of j 2 pi f t divided by minus of j 2 pi f integral over 0 to infinite, we can get x of f is equal to 1 divided by j 2 pi f. While we taking the Fourier transform of unit impulse function, whatever the transform of unit impulse function, del of t is equal to 1 for t is equal to 0, 0 for t should be not equal to 0. Therefore, x of f is equal to 1. Next one, first we can see the linearity property. x1 of t Fourier transform pair with x of omega, x2 of t Fourier transform pair with x2 of omega, then a1 into x1 of t plus a2 into x2 of t Fourier transform pair with a1 into x1 of omega plus a2 into x2 of omega. a1 and a2 are arbitrary complex constants. If x of t Fourier transform pair with x of omega, then x of t minus t naught Fourier transform pair with e power minus j 2 pi f into t naught into x of omega. Else omega is equal to 2 pi f. This is the time domain shifting property of Fourier transform. Next one, x of t pair with x of omega, e power j omega naught of t, x of t Fourier transform pair with x of omega minus omega naught. This is nothing but frequency domain shifting property of Fourier transform. X of t Fourier transform pair with x of omega, then x of a t Fourier transform pair with 1 divided by modulus of a x of omega by a. This is nothing but time or frequency scaling property of Fourier transform. Next, x of t Fourier transform pair with x of omega. There is the x conjugation of t Fourier transform with x conjugation of minus of omega. This is nothing but conjugation property. If x1 of t Fourier transform pair with x1 of omega, x2 of t Fourier transform with x2 of omega, then x1 of t into x2 of t Fourier transform pair with x1 of omega into x2 of omega. Next one, And then multiplication property. x1 of t Fourier transform pair with x1 of omega, x2 of t Fourier transform with x2 of omega, then x1 of t multiplied with x2 of t Fourier transform pair with 1 divided by 2 pi x1 of omega into x2 of omega. Next one, differentiation property. If x of t Fourier transform pair with x of omega, then d into x of t divided by dt Fourier transform pair with j omega into x of omega. Next, frequency domain differentiation property. X of t Fourier transform pair with x of omega, then t into x of t Fourier transform pair with j into d by d omega into x of omega. Parseval's relation, x of t Fourier transform pair with x of omega, then integral over minus infinite to plus infinite modulus of x of t the whole square dt is equal to 1 by 2 pi integral over minus infinite to plus infinite x of omega the whole square into d omega. Now we can see the proof of linearity property. x1 of t Fourier transform pair with x1 of f, x2 of t Fourier transform pair with x2 of f, then c1 into x1 of t plus c2 into x2 of t Fourier transform pair with c1 into x1 of f plus c2 into x2 of f. Formula x of f is equal to integral over minus infinite to plus infinite x of t into e power minus j 2 pi ft into dt. Now we can apply the time domain function instead of x of t. We can get c1 into x1 of f plus c2 into x2 of f. Next one, time shifting property. X of t pair with x of f, then x of t minus t naught pair with x of f into e power minus j 2 pi f naught 2 pi f into t naught. Therefore, x of f is equal to integral over minus infinite to plus infinite x of t into e power minus j 2 pi f t into dt. Instead of x of t minus t naught is equal to m, t is equal to m plus t naught, dt is equal to dm. Therefore, finally we can get the substitute in your above equation. We can get e power minus j 2 pi f into t naught into x of f. Next one, frequency shifting. If x of t Fourier transform pair with x of f, then e power plus j 2 pi fc of t into x of t is equal to x of f minus fc. Finally, for Fourier transform formula, x of f is equal to integral over minus infinite to plus infinite x of t into e power minus j 2 pi ft into dt. Now we can, instead of t, you can substitute e power plus j 2 pi fc of t into dt. Now we can combine these two terms, e power terms, we can get capital X of f minus fc. Next, area under x of t. When x of t pair with x of f, then area under x of t is equal to integral over minus infinite to plus infinite x of t into dt is equal to x naught. Now we can substitute x of f is equal to integral over minus infinite to plus infinite x of t into e power minus j 2 pi ft into dt. Substitute f is equal to 0, we can get the function as x of 0 function. Area under x of f means we can put t is equal to 0, therefore x of 0 is equal to integral over minus infinite to plus infinite x of f into tf. Next, duality property. X of t pair with x of f, then x of t is equal to pair with x of minus f. Therefore, x of t is equal to integral over minus infinite to plus infinite x of f into e power plus j 2 pi ft into df. Now we can replace t by minus t. We can get x of t is equal to x of minus f. Now we can see the assessment. Define Fourier transform. Fourier transform is used for analysis of periodic signals, conversion from the time domain representation to frequency domain representation. X of omega is equal to integral over minus infinite to plus infinite x of t into e power minus j 2 pi ft into dt. List the properties of Fourier transform: linearity property, time shifting property, frequency shifting property, duality property, area under x of t and x of f, convolution property, etc. State linearity property of Fourier transform. If x1 of t pair with x1 of f, x2 of t pair with x2 of f, then c1 into x1 of t plus c2 into x2 of t Fourier transform pair with c1 into x1 of f plus c2 into x2 of f. Fourier transform of unit step function is given by x of f is equal to 1 divided by j 2 pi f. duality property is also known as some difference conjugation property. Time shifting property is defined as x of t par with x of f, then x of t minus t naught Fourier transform par with e power minus j 2 pi f into t naught into x of f. Frequency shifting property of Fourier transform states that x of f minus fc Fourier transform par with e power minus j 2 pi f naught into x of f. Thank you.